Okay, so today's notes. This is another type of frequency table. We've done frequency tables before, but the frequency tables we had earlier was just one frequency table. So this one, it says the table below shows the number of people who own road bikes or mountain bikes and whether or not they ride their bikes to work. So on this frequency table, I've got going this way the bike numbers. So mountain bike, total, road bike. And I've got this way, rides to work, doesn't ride to work. So that's why this is known as a two-way frequency table, because it's comparing two different things. It's comparing bikes to riding and not riding to work. A two-way frequency table. Now notice on this chart, the numbers add up to get your total. So 12 plus 58 is 70, 18 plus 12 is 30, 30, 70, 100. It also adds up this way. So sometimes on the state test, they'll give you a chart like this, but they won't give you some of the numbers. You don't have to do this. But they might leave this one out, maybe this one out, maybe this one out. So they'll leave some blank spots, and then you have to fill them out. And like I said, fill them out kind of using the totals. If 30 is the total, subtract 12, you'll get this one. If 70 is the total, subtract 58, you get this one. 70 plus 30 is 100. So a lot of times on these, sometimes it's a two-part question. The first part may say complete the table. The second part may say something like find the probability a randomly chosen person owns a road bike and rides to work. Well, owns a road bike is everybody here. This is road bike. Rides to work is everybody here. So that means between the two places where they intersect is 18. So 18 of the total people they talk to owns a bike and rides to work out of 100. Now, you can leave it 18 out of 100. You can change it to 0.18. You can change it to 18%. You can reach to 9/50ths. Like I said, unless they specifically tell you what they want the answer to look like, they would accept any of those, as long as it's equivalent. So let's take a look at some more examples. Are you kind of that first one that they kind of did out? So this one, we have a chart that's comparing what shift people work and how much sleep they got. The shift and the sleep. So number one says sleep less than 8 hours and works on the night shift. Sleep less than 8 hours, that's here. Night shift is here. So I see where they connect. They connected at 12. So 12 over 100, because we're talking about everybody here. We want to know based on everybody they surveyed, what did we get? Again, you can leave it like this. You can change it to 12%. It could have also reduced to 4 over 25. Any of those would work. Nope, 3 over 25. So number two, sleeps 8 or more hours, works on the day shift. So 8 or more hours, day shift, I look to see where they connect. They're connected at 16 out of the 100. So 16 of the 100 fit both categories. So it's still an and, but instead of taking the time to do all like the multiplication stuff that you normally on the end, it's set up that you can just find it. Again, you can change it to 16%. You can divide by 4, get 4 over 25. Any of this will work. So number 3. Number 3 says sleeps 8 or more hours. 8 or more hours. Night shift, well, that's 58. Out of 100. Again, you could write it any of these ways. So those are your answers. The front. Any questions on the front? Now, chances are on the test, they probably aren't going to ask it this way. The ones on the test generally are asked like the ones on the back. So let's look at the back, because they're slightly different. So on the back here, it says, what's the likelihood that you would pass your next test? Would your chance be better if you studied more? This type of situation is called a conditional probability, where the probability is affected by another event, which in this case is study. So on these, it says the term given tells you that the category you're concerned with is an event that's already happened. So we want to know, what's the probability a randomly chosen person failed given he studied 4 more hours? So studying 4 more hours is everybody here. This is the group that studied 4 more hours. They really wanted to get a good grade on the test. I want to know, based on just that group, how many people failed. Well, failed was only 2. So instead of doing it out of everybody, which is 100, I'm only doing it out of the group I'm concerned with. So 2 out of the 36. Because there's 36 total people that studied more than 4 hours. So 2 over 36, I can change to 1 over 18, I can change to 5.6%, any of those will be fine. So that's a conditional. So instead of looking at everybody that they surveyed, they're only looking at one group that they surveyed. They're looking at one group. So let's look at some examples of these. So I've got cars and trucks and their colors. That's my two-way frequency chart. So number 3 says, what's the probability of red given it is a truck? And they're not going to write out necessarily given it is a truck. They might put the line, they might word it different ways, but it's out of the truck group. So basically what I'm looking for is my red trucks out of, not the total like I normally do, but just out of the trucks. Because I only care about the truck numbers. So I'm trying to figure out the probability of red trucks out of the trucks. Well, how many red trucks were there? So there was 4 red trucks. How many trucks were there? 10. 2/5, 40%, any of those would be fine. So since it's a conditional probability, I'm only looking at certain groups. So like number 4, it says blue, given that it's a truck. So I'm looking for my blue trucks out of trucks. So blue trucks, how many blue trucks were there? Blue trucks. 6. So 6 blue trucks. How many trucks? Still 10. 3/5, or I could write it as 60%. Any of those are fine. Number 5, what's the probability that a randomly chosen vehicle is a car given it is blue? So instead of putting that little line there, they kind of wrote it all out. But it's still the same way. It's car blue out of the blues. So I'm looking for car blue out of blue. So car blue, how many car blues are there? 10. So 10 on top. Out of blue, how many blues are there? 16. Which is 5/8. Now, like I said, typically on the state test, they ask one of these. This is normally how they're worded. Now, I'm going to pass out the worksheet. I'm going to do the first set with you, and then the rest is homework. Let me get these passed out. All right, let me switch it over. So on this worksheet, basically on this worksheet, I've got 1, 2, 3, 4 charts. And then questions that go with each chart. So we're going to look at the first chart. So the first chart, we're comparing people that exercise compared to whether or not they caught a cold. That's my first chart. We're going to answer these questions based on that. Now, it's not like a lot of the worksheets where the front is one type, the back is the other type. These are all just kind of mixed up. So number 1, how many patients exercised? This is just a number. What's my total exercised?
38.
38. So that's my first answer, just 38. Well, the next one's asking for a probability, so I'm probably going to do it as a fraction first. It says, what's the probability that a randomly chosen patient, so that's out of everybody, caught a cold and did not exercise? So what number caught a cold and did not exercise?
Wait.
Cold, not exercise. Cold, not exercise, 10. So 10 out of everybody, because it says a randomly chosen patient, which would be 1/5. Or like I said, you could do 20%. Any of those would work. The next one, what's the probability that a randomly chosen patient exercised and did not catch a cold? So exercised, did not catch a cold. So what number exercised and did not catch a cold? Well, it looks like 30. So 30 out of everybody, which would be 3/5 or 60%. So that's kind of like the first set. I'm just looking at the probability based on everybody. This last one was different. It says, what's the probability someone did not exercise given they did not catch a cold? So this is the one that takes both. Did not exercise, did not catch a cold. That's the first number. Did not exercise, did not catch a cold. Well, that's 2. Out of did not catch a cold. So what number is going to go in the bottom of that one? I didn't hear you over that part. 32. Which is 1/16. And I can change that to a decimal. I forget what it is. Because it's out of just one of the groups, not everybody they talk to. It's only out of the one group. Now, let me kind of scroll through here. Everybody okay in this first 4? Three or 5, 6, 7, basically the same thing. They give you a chart, answer the questions. Read the questions carefully. 8, 9, and 10, they have decimals up here as opposed to straight numbers, but you're still going to do it the same way. So you're still going to come up with a fraction But because the fraction has a decimal on top, decimal on bottom, just go ahead and divide and get 1 decimal. So you can't really reduce the fraction because there's decimals. But you're still going to set it up the same way, even though there is decimals. So that's this one. And then the last one, basically the same thing as we already did. Now notice they kind of have 2 questions that look almost identical. This is red berries given lobed leaves. This is lobed leaves given red berries. They will not give you the same answer. They are not the same answers. So this is the homework for tonight.